Hi my friends, nice to have you. Welcome back to question 11, vectors and matrices. And in this video we're going to be working out question 11 part B, and that would be part 2 of B. Okay, in the previous video we had worked out part 1 where they asked us to calculate the values of A and B in the matrix M0 A, B, 0. And here, if you notice, I made note of my values of A and B, and A was equal to 1 and B is equal to -1. Hence, we have our matrix. The M is equal to 0, 1, -1, 0. So all I did really was to substitute the values for A and B in the original matrix. We had calculated really this matrix algebraically. So if you're not sure as to how to go about that, you could watch the previous video in the playlist, okay, the video that would come before this one that you're watching, if you want to get the basic concept as to how we found values for A and B. However, in this video what we'll be doing, we're going to be describing fully the transformation of M, which is the matrix 0, 1, -1, 0, okay, that maps the object point R 7, 2 onto its respective image point R prime 2, -7, and T -5, 4, and that maps the object point T onto its corresponding image, which is 4, 5, T prime. Now let's quickly get into it. Let me just pull this up a bit. So there we have it, my friends. Okay, saying before, to describe a transformation. For example, there are some matrices, right? There are some matrices that represent special transformations. For example, if there's a reflection in the y-axis, any line that passes through the origin, if you notice the y-axis cut the x-axis at 0, so it passes through the origin. For any line that passes through the origin, if a point is reflected in that line, you have a special matrix to represent that reflection. Also for the x-axis, which is this horizontal line here, if a point is reflected in the x-axis, you have a special matrix that represents that transformation. Also for the line y equal x, which is a diagonal line running running along this path that my pointer is presently going, okay, and also the line y equal -x running in the direction that my pointer is going, and both lines passes through the origin. Now if a point is reflected in those lines or an object, there are special matrices that represents those reflections. So basically, when given a matrix and asked to describe the transformation, if you're not sure or if you're not clear, you could always for example, as I have done here, draw up a Cartesian plane and you could plot the points, okay, and for in this exercise I chose to plot R and R prime. So for your exercise you could do it for T, the object point T, and T prime, okay. So what I'll be doing, these matrices, after working with them, after getting familiar with them, you will know them by looking at it. I could just write down the description for this matrix that represents this for the matrix that for the transformation which this matrix represents. However, for the persons who aren't sure or aren't clear, I can show you how you can come up with your description. So that's the basic concept that I'll be looking at. So that's why I've drawn the Cartesian plane here. Now basically what I did, okay, I have plotted my point R and its respective image point R prime, which is 2, -7. If you notice, I have a 7, 2, that's R here, and I have my 2, -7. So basically, when describing a transformation, first, if you're not clear, you could go by trial and error, okay. So basically, I am going to be writing down the 4 types of transformation that we're being tested on. First one is the translation, okay, and the second one would be the reflection, okay, reflection. Let me just pause the video and write them down quickly. So here we have the 4 types of transformation that they are testing us on. So you can always do a process of elimination. For example, we know that if it's a translation, then the vector would be t equals some x value over some y value if it's a translation. However, if you notice, the matrix M is a 2 by 2 matrix. The matrix that represents a translation is a 2 by 1 matrix, okay? Meaning that the matrix at the top, matrix M here, has 1, 2 rows and 1, 2 columns. So that's what I mean by 2 by 2 matrix. And the matrix that represents a translation has 1, 2 rows, okay, and 1 column. Rows run horizontally while columns run vertically, okay? So basically, since the matrix that represents a translation is a 2 by 1 matrix, and the matrix that we're trying to describe is a 2 by 2, then obviously we can rule out a translation. Okay, now an enlargement, as the word suggests, the object is getting bigger, so this we could just right away eliminate an enlargement. So let's check. It's between a reflection and a rotation. So let's look at the characteristics of a reflection. When an object point is reflected in a line, okay, it must be, the image point must be the same distance away from the line as the object point. Okay, now if you look at this carefully, we have r here and we have r prime down here. Now for r, if it was a reflection in the x-axis, then I could count 1, 2. My object point is 2 away from the x-axis. Now let's count on this side, 1, 2. So if it was a reflection, then r prime would be here. Now it's not, so obviously it's not a reflection. Okay, so these are just some basic pointers, okay, that you can use when you're describing your transformation. So obviously it must be a rotation. So let's check it out now. How do we check if it's a rotation? So if it's a rotation, how can we describe our rotation? First, what I'm going to be doing, I'm going to use a line segment to connect. Okay, I'm going to use a line segment now to connect my object point to my center, because the special relationship, because we have a matrix that represents it, that simply means then my center of rotation must be the origin. Because basically what I'm going to do, you should use your ruler. I don't have a ruler in the software, so you should use a ruler since it's a rotation, and we're going to connect the point. And let me just brighten this a little bit more for you. Okay, I'm going to use my ruler, and from my center I'm going to connect a line segment to my point. That's ugly. Let me just get rid of that. I'm going to connect my object point to my center of rotation right there. Okay, and then I'm going to draw another line from my center to connect that to my image point. Okay, and you use your protractor now, okay, and you're going to measure this angle, and you should get a 90-degree angle right there when you use your protractor and measure this angle. Now if you notice, the object was here, so it's going in a clockwise direction. So this direction represents a clockwise direction, so the object point has moved in that direction. Okay, so that's a clockwise. Now in math, a clockwise direction is a negative direction. All right, so there we have identified what type of transformation it is, so we are going to describe it now. I'm just going to pause the video a bit. Well, here we have described our transformation, and we have stated this is a rotation with center being 0, 0, the origin. And if you notice, here is my center, 0, 0, the origin. And we're stating that through an angle of 90 degrees, and we have connected the points. Okay, and when you connect the points using your ruler and you measure the angle with your protractor, you would get a 90-degree angle there, and we're going in a clockwise direction. Okay, so I'm moving from this point R and I'm coming in that direction, a clockwise direction. Now it's very important when describing a rotation, you should always give the center of rotation, which I've stated here, the angle of rotation, which I've also stated there, 90 degrees, and the direction of the rotation, which is a clockwise or a negative. So you could say a clockwise direction or a negative direction. Anyone would be okay. Okay, and that's how you describe the transformation. Okay, guys.